Hello and welcome back to Historical Geology. I'm going to look today at the Fossil Lab Part 2 on brachiopods, mollusks, and arthropods. And again, just like last week, make sure you read through the text of this lab and all the figures, and you'll see that the questions are referring back to the text in this lab and some of these figures, the different body parts, the different types of brachiopods, and the types of different brachiopods. This is important to read because there's a couple of questions about different periods during the Paleozoic when brachiopods are really abundant. And for example, the orthids were prevalent or abundant in the Ordovician, whereas the sporiferids were prevalent in the Devonian. So anyways, read about these because there's some questions they're going to ask about these later on. And this next figure is a different, so you use this to identify some of the brachiopods that I present later on in this video or in this lab as well. You'll see there's some questions that are going to ask you to identify some brachiopods. So again, here are the questions. You can look through these and go back into that preceding text to answer these questions, especially about habitat, about Lingula. It's usually a intertidal or littoral organism. You'll see that there are different brachiopods and what age group. That's what I was talking about. So you can come and answer these. I do have 2 or 3 brachiopods I'm going to show you at the end of this video that you'll identify in the fossil worksheets at the end of the lab. The next phylum is Mollusca, and these are the bivalves, gastropods, and cephalopods. Those are the 3 we'll be looking at because they're really important in the fossil record. The chitons or polyplacophora here are not as abundant, but I mention them as we go along here. So remember, a valve is the one shell half. So bivalves, like clams, have 2 shells, right, that come together, and they're usually symmetric between the shells. So read about the different parts of the bivalves, and especially this figure here, because you'll be asked to label some of these features on a picture of a bivalve. Here are the different bivalves. So you'll be using this figure, figure 7, to identify pictures of bivalves I have, and I have 2 that I'm going to show you later on for the worksheet at the end of the lab. And then the gastropods are the snails, so read about the different features of the gastropods, and then especially this operculum, which is sort of like a little hatch that when the snail crawls into its shell, this thing comes along and makes a really tight seal to further protect the snail inside its shell. And then this figure here is again on the different types of fossil gastropods. Obviously, there are many more. This is just a sampling. And another important feature, and you'll see it really in this question number 2, is that snails, if you look inside of them, it's one complete cavity or hole. There are no partitions or septums or chambers. Like the chamber nautilus does have different chambers, and the animal only lives in the outermost living chamber. So that's a major difference between the gastropods and the cephalopods. And here's some pictures of gastropods. So again, you'll be looking at these pictures and then going back to this figure 9 to identify those. And I have one. I only have 1 gastropod to show you at the end of the lab. And then the next group are the cephalopods, which include octopus, the cuttlefish, squids, the nautilus, and the fossil ammonoids. And again, read about how I describe these and really the 2 major groups, the nautiloids and the ammonoids. But they're very similar. Ammonoids went extinct at the end of the Mesozoic. And then this is a good picture that shows the living chamber, and then this siphuncle that's a calcareous tube that connects the inner chambers or camera, where the animal can either expel or add gas to these chambers, and it'll allow the animal go up or down or to be more buoyant or less buoyant. And in the living position, you can see the living nautilus, the shells are always in this position. We have them a little different here only to emphasize the different suture patterns. That's an important part of trying to identify, or at least grouping the nautiloids into different, either the Paleozoic or Mesozoic. It's the degree of complexity of the sutures. You can see in the nautiloids, which date back to the Cambrian, we see that the sutures are not very complex, but as we go into the Devonian, we see a little bit more complex sutures, and then really the ammonoids start really making complex suture patterns. And you can see that these are going to be more in the late Paleozoic to Cretaceous or Mesozoic time over here, these more complex suture patterns. The different types of nautiloids, and then figure 11b here is on the ammonoids. So again, you'll be using these to help you identify some of the ammonoids. I think I have 3 that I'm going to show you at the end of the lab. And then there's a little bit about the belemnites. Read about the belemnites. The key thing about belemnites is they have this internal guard, which when it's fossilized, it usually leaves like this brown. Yeah, so the unchambered guard portions of fossil belemnite shells are often bullet-shaped and takes on a brown coloration. And then you can answer the questions. Again, remember the siphuncle here in this ammonoid or this nautiloid allows the animal to add or remove gas from the inner chambers. So think about if the animal added a lot to gas, this thing would float up, right? So think about how that would be beneficial or not beneficial. And then as we go along here, there's a couple of questions. Again, geology, we haven't really talked about faults that much, but again, this looks to be a normal fault. And I labeled some of the features of faults, the footwall, because you can walk on the footwall, and then the hanging wall would be up above. In this case, looks the hanging wall has moved down, so you can say something about what's going on there. And then here we're going to identify a couple of different nautiloids, and again, you want to use figure 11a up here on the different nautiloids. And then I think I have some ammonoids. Yeah, so here are some ammonoids. So it led on to the next page here, but take a look at the suture patterns, and that may help you identify what ammonoids these are. And finally, the last bit is on the arthropods, and really the most important one we'll be looking at are the trilobites. Trilobites were very abundant in the Paleozoic. They're really good index fossils for different periods in the Paleozoic. They had a very complex compound eye here, as you can see, and I will show you 2 trilobites at the end of the lab, but you can kind of look through here, answer the questions, use this figure 14 to help you identify the trilobites in the pictures as well as the one I'm going to show you later on. And then, yeah, here you identify these using figure 14. Now, the last part is on identifying these different fossils. So again, we're going to have a specimen number, give me the common name, phylum, well, I'll kind of give you those, class if possible, especially for the mollusks, and then try to figure out the symmetry. And then if you can identify the organism using the sheets in this lab, give me the range. And if you can identify the type of fossilization, and then put that in there, and then what clue really helped you with that identification. So let's look at the first sample. This is sample number 14. And one thing I noticed about this organism, it has this nice hinge line there, and then it has one shell that's larger than the other. So, and the symmetry has to go, in this case, through the shell, not between the shells. And note that this does have a pretty pronounced succulus here and a fold on top. So it's going to be some sort of brachiopod with a relatively straight hinge. That's sample number 14. This is sample number 15, which is another type of brachiopod. Again, you can see it has that sulcus, very deep sulcus in this case, and you can see the fold up on top. And again, the symmetry, here's the hinge line over here, but the symmetry is going through the shells. And also note that the hinge line, unlike this first one, the hinge line for number 14 is very straight, but this one, the hinge line is like a V pattern. And there is one group of brachiopods that have this very pronounced V pattern hinge line, unlike number 14. All right, so this is 15 and 14 there. Next we have, in fact, both of these are the same. They're just different sizes, 2 different trilobites. And so again, in this case, what you'll want to do is look at the different parts of the trilobite and see if you can identify what this animal is. So this is sample number 16, this trilobite, sample number 16. Sample number 29 is a really teeny trilobite. You can see them in there. And this one I do have in the lab. You should be able to find this one on your data sheet, but it's that small little there it goes, into focus there. So small little trilobite there. Sample number 29, and we'll call this sample number 30. And you can tell it's something that's planispiral, some sort of nautiloid. Actually, this is an ammonite, and you can tell. Another thing to notice that it has pretty complex suture patterns in here. You can see really these complex. This would be like the saddles and the folds that are described in the text. So really complex ammonoid here with planispiral symmetry. Sample number 28 is the same. There's two bits of it, and it's another type of ammonoid. In fact, I think this one's actually a nautiloid. So look in your nautiloid, and it has more of a straight shell. Some of the features of this one here. Sample number 28, another nautiloid. This bullet-shaped guard, and you should probably know what this one is. Remember, the animal lived over this, the soft parts, but this is all that's left in the fossil record. Number 27. Number 19 is a bivalve mollusk. So it's some sort of clam, but what's unusual about this clam, and you can tell it's because it's only one shell. Clams, remember, you often find it just one half because they rest open. The other valve of this bivalve is much smaller. So this is one of the only bivalves that doesn't really have two identical or nearly identical valves. One is larger than the other. And also take a look at this kind of growth pattern it has, and that's very indicative of this bivalve. So look in the bivalves, and you'll find which this one is here. That's number 19. And then number 20, actually this is number 24. So this is some sort of gastropod, and it has that coney spiral symmetry, and it has that whorl, and then there's an aperture there at the opening at the top. So that's number 24. And finally, one more bivalve mollusk. And I think this is the one we had a picture of. But number 20, you can see this bivalve mollusk has this really intense beak over here, and it's off to the side. So sample number 20. So see if you can find that one. All right, well, let's stop here for now.